Hi, everyone. So we are going to talk about a project that we were working on and at PSC. That when we apply for this, speaking about this, we were working on this, but now we have stopped working on this. So we are going to go through what we were doing and the reasons why we stopped working on this. So a little bit of the retrospective of a project, let's say. I started working in 2022 on the zkVM that at that moment PSC was working on. That was based on Halo 2 kind of a plonkish arithmetization, and because it was very complicated to build something like that on top of Halo 2, it's inevitable that you need to abstract things. So as an engineer, I found there like a treasure trove of really interesting abstractions to be able to build the zkVM on top of Halo 2. A lot of layers on top of the Halo 2 to be able to reason about it and to kind of like, abstract on it and build what we require. And there's like things like the state machines. It seems like was like the right level of abstraction to think about proving computation on top of a plonkish arithmetization, and the cell manager that was used to kind of place things in a more efficient way on the plonkish table, and also how to combine like composability with something that was called the supercircuit and subcircuit. And all this was built when I started working here, but I started kind of learning about it. And I found like this idea that these abstractions actually, if they are made in an accessible way, could make much more easy for the average developer to develop ZK apps, and that something like this could help multiply ZK apps development. And with that, we started Chiquito first as a DSL in Rust. Then we added a Python frontend to make it even simpler, with the idea that developers didn't need to learn Rust, they could do it on Python. And then after bringing it to several hacker houses and working with builders at an experimental level, with more information about how it should be built, we started kind of creating our own front-end, our own parser for a language that kind of has a similar syntax to Circon, but has state machines and more things. So in the end, what we implemented, the state machines, that are as the kind of the definition, like the constraints of the transitions of state machines are kind of the circuit, and the witness is the trace of an instance of the execution of these state machines. And that's kind of like the main abstraction at Chiquito. And then with the cell managers, we abstract how that is converted to the plonkish table and how the witness is arranged in an efficient way and is independent, so can be configured in different ways to try different things. Then another thing that we built is like arbitrary boolean expressions compilation to polynomial identities. So the constraints are expressed as polynomial identities, and we built a system that any boolean expression, as complicated as necessary, it will be automatically compiled to this. And we kind of develop a mini theory about how to build this that can be used in other languages, like how to compile any Boolean expression into polynomial identities. Then we also, like, compilers has to optimize, and through optimization can get to better performance than, wow, I'm going super slow. So yes, we did more things, and this is how it looks, the code. And yeah, you can, like, for example, here you can see like arbitrary Boolean expressions that are compiled automatically to constraints. And we saw like it was super easy, and users really quickly could develop like complicated things like Blake2 hash that in the zkVM we couldn't implement on top of Halo 2 normally with it. And we checked that it has the same performance as manually doing with Halo 2. And we found some things that can be better. And then the reasons to sunset it is basically zkVMs, the race of zkVMs make us reason that now we are in a kind of zkVM era, that the applications we want to build now are probably better built on zkVMs. And thank you for all the people participating in different stages on Chiquito, PSC engineers, researchers, and grantees. And yeah, thank you very much.
Thanks, Leo. Question time.
I had to accelerate a lot.
Any questions? Oh, there. I'll go closer.
Oh, I wanted to throw it.
You want to throw? You can do next.
It's okay. Hey, Lance.
Yo, what's up, Leo? So question on custom constraint systems. I saw that there was one of the libraries that you all use. When it comes to CCS and zkVMs, are there any zkVMs that are implementing for that to go from like Plonk to air?
But that wouldn't be like to go from Plonk to air. That would be kind of a easy translation, I think. Like not a VM, but from Plonk into air would be kind of easy translation, no? Because the difference is kind of how the rotations work in the arithmetization. So we actually, yeah, we implemented the backend as Powder, that is kind of air. So
Powder?
Yeah, Powder, yeah.
Yeah, okay.
One of the, yes, I cannot show this. Like,
Yeah, I'm familiar.
Yeah, so we implemented a backend for Powder that is kind of air, yeah, so, yeah, it's easy, Plonk is, and even CCS, we implemented the backend in CCS, Sonove, so yeah, it compiled to, we didn't have time to check the performance on Sonove, but it was something that was compilable to many different proving systems.
Dope. Really cool.
I think there's a question here. Yeah. Okay. You want to start?
Who?
This one. Oh.
Hi, thank you. Nikolai from Terminal 3. A few questions, actually. First, can I verify your proof on chain, like in BN254? That's basically the only on-chain verifier now.
Yeah.
And then you said you'd made Python, but can I do Rust code and compile it? And because most of cryptography is in Rust, so Rust is very useful here. And
let's do these two, and then if you want.
Okay.
So you don't forget. So the first question on chain, yes. So we for the zkVM we implemented a verifier in Solidity for the Halo2 proof. So as long it depends on the proving system that you use in the backend, if it can be verified on because it's kind of independent on the proving system, can compile to different proving systems, and they generate different proofs. So it depends on that. And the second question, Rust, is built on Rust. Chiquito was built on Rust, and then we put like a parser, a frontend. But yes, you could interact and connect it with other Halo2 circuits built on Rust and kind of actually integrate it together. And another question? Or,
Okay, we have one more question. Okay, there.
yeah, better you throw it. No?
You want to throw it again?
Okay.
Last opportunity.
Oh,
Too short.
so bad.
So I actually not sure I understand the difference between a zkVM and a zk compiler. Like a zkVM takes your Rust code, translates it into, like, let's say RISC-V instructions, and proves that. But
Okay. Yes. So a zkVM is one circuit that its witness is the trace of the execution of an instruction set. So the zkVM is not a compiler; it's a circuit that takes as witness the trace of the execution and proves that you have executed correctly the program. So in that case, you compile Rust to this instruction architecture, and then you execute it and you get the trace, and that's verified. That compiler takes some kind of description of what your circuit does and actually kind of outputs a circuit itself. So you could build a zkVM on a DSL in a language. I don't hear you, yeah.
so what actually executes the code? Like, what does a proof proves if it doesn't prove correct execution, right, with the compiler?
Yeah, with the compiler, you generate a circuit that proves something about a witness. So a zkVM is a type of circuit, no? Is a type of circuit that proves the execution of the trace of a specific instruction set. Okay, but a circuit can prove any witness like follow certain properties, certain constraints. In the case of the zkVM, the constraints are the correct execution of the instruction set. Happy I knew that question. I knew the answer. If they ask something different.
I don't think we have time for one more question, but please feel free to talk to Leo after his talk.